All right, so to get started with our learning goal today of finding probabilities using Table A, first let's go over the 68, 95, 99.7% rule. So this rule just states that if we have a normal distribution with our mean in the center, it says that 68% of our data lives within one standard deviation of the mean. So we have plus 1 standard deviation and minus 1 standard deviation. So that would be 68% of our data living within that range. So 34% and 34% within this range. Now we also know that 95% of our data is within 2 standard deviations. So we have plus 2 standard deviations to get here and minus 2 standard deviations to get here. And that'll give us 95% of our data. So if we're looking at what's left, let's see, if we have 68 in the middle, that means we have means we have 27 left over and 13.5% in these little sections here. So we have 13.5%. Now the last piece is looking at 99.7%. So that says 99.7% of our data lives within 3 standard deviations. So we have plus 3 times the standard deviation and minus 3 times the standard deviation. And if we look at what's in these tails, what's left here, so now we have 99.7, and we just need to take out the 95%, so that'll give us 4.7% left. And that'll give us 2.35%. So 2.35% left over. So a lot of the problems that we're going to be doing, some of them you can just do with the 65, 99.7% rule. If we look at just the standard normal distribution, the standard normal distribution always has a mean of 0, so a population mean of 0, and a standard deviation of 1, which means all of these little tick marks are now going to be 1, 2, 3, and -1, -2, -3. And we will always notate that with capital N, parentheses, our mean, which is 0, comma, our standard deviation, which is 1. When it comes to looking at the standard deviation and the mean of something, we can find something called a z-score. So a z-score is the number of standard deviations a value is above or below the mean. If z is positive, that means it's above the mean. If z is negative, that means it's below the mean. So let's look at an example so we can figure out how to calculate z-scores. So here we have some scores from a recent quiz in a class, and here's all the list of the scores. Now, I've asked you to calculate the mean and the standard deviation here. I've already done this in my calculator using the 1var_stats command, so use the 1var_stats command to enter in your numbers, and that'll give us a mean of 25.04 and a standard deviation of 13.89. And our formula for z-score is going to be z equals our value that we're interested in minus the mean divided by the standard deviation. So in part B here, we're looking at a score of 45. So we want to calculate and interpret that z-score. So that means our value here, our x, is 45. So our z-score is going to be 45 minus our mean, which is 25.04, divided by 13.89. And if we do that, looking at, again, 45 minus 25.04 divided by 13.89. And that'll get us a z-score, or a z, of 1.44. Meaning, for our interpretation, Paul is 1.44 standard deviations above the mean. And remember, our mean is 25.04. Let's look at another example. So in this case, we're working with the same numbers that we did before. Carl earned a 2 on his quiz. So let's calculate and interpret his z-score. So again, our formula for a z-score is x minus our mean divided by our standard deviation. And for this particular problem, our x is 2. So we are going to do 2 minus 25.04 divided by 13.89. So if you do that math, we should get a z-score of negative 1.66. And when we interpret this, we say Carl is 1.66 standard deviations below, since it's negative, the mean of 25.04. And let's look at a more complicated example here. So the scores on Mrs. Fly's next quiz had a mean of 32 and a standard deviation of 6.5. So this is kind of going back to our first z-score that we calculated here. Paul earned a 47 on this quiz. So which quiz did he perform better relative to the rest of the class? So remember, on quiz 1, he had a z-score of 1.44. Now let's look at quiz 2. So for quiz 2, we are interested in looking at the 47. So we want to find out how he did. And we are given this time that the mean of this quiz was 32 and the standard deviation was 6.5. So remember our z-score formula, x minus x bar divided by the standard deviation. So all we need to do is plug those numbers in. So we're looking at 47 minus 32 divided by 6.5. So go ahead and do that in your calculator. And that should get you a z-score of 2.31, which means that Paul performed better on quiz 2. Since he had a higher z-score. Okay, so before we look at actually calculating those probabilities, we need to learn how to use table A first. So let's look at an example z-score here. So let's say we have a z-score of negative 3.17. What table A is going to do is show you the probability of getting less than that z-score. So if we want to find the probability of a z-score less than negative 3.17, we are going to use table A. So in table A, you want to search for the first part of your z-score. So right here for negative 3.1 and the rest of your z-score. So that's going to leave 0.07 left. And what you need to do, let's actually get that in a different color there. What we need to do is look down this row because that matches with the first part of our z-score, and look down this column because that'll match with the second part of our z-score. And what we're going to find is that that row and that column will match up with one probability in particular. So using table A, this will get us a probability of 0.008. And that'll get us the probability of less than that z-score. Okay, so let's look at tying it all together with everything that we've done so far. So suppose that the scores of all the quizzes in Ms. Chauvet's class were normally distributed with a mean of 83 and a standard deviation of 5. So first, let's sketch the curve that describes the distribution of scores on those quizzes. So we're looking at a normally distributed curve. So we're looking at something that kind of has a bell curve in the middle. And we have a mean of 83. So when we start our notation here, we're going to have that n, parentheses 83, and then it's comma, our standard deviation. So we can add and subtract one standard deviation. That way we have some numbers going on here. So we're looking at 88 and 78 to start off with. For an AP exam, this would be a good enough answer. You can go out the 2 and the 3 standard deviations, but now they know that you know what you're doing. And if we look to see what percent of those scores are between 73 and 93, well, in this case now we do have to add another standard deviation on the top. So we're looking at 93 and 73. And since we're using the 68, 95, 99.7% rule, we have 73 and 93. Those are both 2 standard deviations away. So remember, 68% fits within plus or minus 1 standard deviation. 95% fits within plus or minus 2 standard deviations. And 99.7 fits within plus or minus 3 standard deviations. So that tells us 95% of scores are between 73 and 93. Let's look at another problem, not using the empirical rule this time. So scores greater than a 90 earn an A. So if we want to find percent of quizzes that earned an A, we need to do a little bit of all the work that we've done here. So we have our mean and we have our standard deviation. Let's get a couple of curves down. So we know that we have our mean of 83, and we are interested in finding out how many are greater than or equal to 90. That's what we're looking for here. So to do that, we need to kind of standardize our values here so we can look at standard deviations and all that too. So we're looking at 90 minus 83 divided by our standard deviation, because remember that is our formula. So if we do that, we will get a z-score of 1.40. And remember, this will give us probability of scores less than 90 when we do it on table A. So here we need to use table A. And for table A, again, if we have our table here, we want to look for the first 2 numbers in our z-score in the rows. So we're looking at 1.4. And the second part, so that third digit in our column. So in this case, we're looking at 0.0. And if you look at table A for that, we should get a probability of 0.9192. But remember, this number is less than 90. So we actually have to do 1 minus that. So 0.9192, and that'll get us 0.0808 as our probability of getting a 90 or higher. You only do the minus if we're looking for greater than. If we're looking at what percentage of scores now fall in between two numbers, we need to do a couple extra steps here that we didn't do before. So again, we have our curve with our mean, and this time we're looking at 71 and 95. And we want to find out what is in between those two numbers. What is the probability of getting in between that? So this time we need to take two separate z-scores. So we need to take the z-score for 95, and we need to take the z-score for 71. So go ahead, take a second to fill out those z-scores. Okay, so when you do those z-scores, we should get positive 2.4 and negative 2.4. So again, we need to use table A here. So when we use table A, let's just look at the negative 2.4 as our example. So you want the first part of your z-score, so the first two digits with the sign, so negative 2.4. And since there's no real digit after that, we can assume that that's a 0. So we look for 0.0. And the cell that matches up with that, so remember you want to match up row and column together. So that particular z-score should get us 0.0082. So 0.0082. And if we do the same thing for a positive 2.4, we will get 0.9918. And since we want to consider just the area between these two, we can take out everything less than 71. So we can actually take these two z-scores and subtract them. Just take the bigger one minus the smaller one. So if we do 0.9918 minus 0.0082, that's going to get us 0.9836. And that becomes our area, or our probability, and our percentage between 71 and 95. We have one final step with these types of problems before completing everything we need to know and achieving our learning goal. So once again, we are dealing with the same situation, a mean of 83 and a standard deviation of 5. This time, we want to find the actual value that would place a student in the 20th percentile in the class. So remember, percentile is the number of values, so the percent of values equal or less than. So in this case, the 20th percentile means 20% equal to or less than. So we can start out with a curve. And remember, we have our mean of 83, with our notation 83, 5. And this time, we're not really sure what value is going to go here. But we do know that whatever it is, that area is going to be 0.2. So what we need to do is use table A. So in the way we're going to do this is, again, we have our table. And what you want to use table A for this time is find the cell that has as close to 0.200, I suppose if you're rounding up 4 decimal places. So you want to find what z-score is the closest to that percentage as we can. So take a moment, kind of look through your table here and see what you can find. If you look through table A, you would have seen that the part that matches with the correct row would be negative 0.8, and our correct column would be 0.04. And that'll actually get us a probability of not exactly 0.200, but 0.2005. Because that is the closest that we can get. So that means we are looking at a z-score of negative 0.84. So now that we have the z-score, we can use it in our formula, which, remember, we don't know our value. That's what we're looking for. And we know our mean and we know our standard deviation. Now we also have a z-score. So we're going to plug this in. 0.84 negative is equal to x minus 83 divided by 5. Now it just comes time to do some simple math and algebra here. So you'll multiply both sides by a 5. So you'll multiply negative 0.84 times 5. And that'll get you a negative 4.2 on the left side. And all we're left is x minus 83. So we can just add 83 to both sides. So if we add 83 to both sides, that'll get us an x value of 78.8, which will give us the score of a student who would be in the 20th percentile for this class.